Hello, everyone, and welcome to the second class in Florida Data Science Academy's Introduction to Data Science. I'll be your instructor, Dylan Sinnickson, and in class 2, we will be continuing our discussion with basic functions that are essential for understanding some basic statistical principles and performing some basic analyses in R. We'll also be loading some R packages, and we're going to be working with random numbers and doing some plotting later on in the course. So I'm going to start off by actually loading an R package. So if you want to load an R package, you go to the bottom right-hand panel and you click on Packages, and then we're going to click Install. And the package that we're going to be loading today is the Zoo package. So what I'm going to do is just simply type in Zoo in this Packages window, and we can click on Zoo and then install it. And then you can see in our R console, R is working on loading this R package. And if you're not familiar, there are dozens of hundreds and hundreds of different R packages that are used in this programming language. And a package is essentially a collection of algorithms and functions that help us perform some different analyses and methodologies in R. So after we install our package, then I'm going to actually have to load it in. So to load an R package, I'm going to call the library function. You can see that when we type library, it shows up in blue. And then I'm going to type the function of interest, the package of interest, which is going to be the Zoo package. And then I can simply hold Control and Enter, and then we can formally load in that Zoo package. And the Zoo package is going to help us work with dates and times in R. So after we install and load that R package, then I'm going to write a note to myself, which is going to be called simply class 2. And then I'm going to write another note to myself, which is going to be more basic functions. And the first task that I'd like to work on today is I need a vector of 10 100s. In this first task that we're going to work on, I just simply want to repeat the number 100 10 different times. So what I'm going to do is give myself a little bit of space, and I'm going to create an object called hundreds, which is going to store a vector. So essentially just a sequence of numbers. We're going to hopefully store the number 100 10 times. And in order to do that, I'm going to use the repeat function. So we're going to, it's actually formally known as the rep function, but it stands for repeat. So the first argument of this rep function is going to be the number that I want to repeat, which is going to be the number 100. And then I'm going to use this each argument, which is going to signify how many times I want to repeat the number 100, and that's going to be 10 because I want to repeat 100 10 different times. So I can hold Control and Enter on line 8, and we can see in the top right-hand panel, we have an object called 100s, and I can actually print it out here on line 9, and when I call the object hundreds, we see that the number 100 is repeated 10 times. So that looks good, and the next task that I would like to do is I want to create a vector of from 60 to 100 at intervals of 5. So this is going to kind of signify some realistic grades that you would find in a class. So you can think of this as maybe you're a teacher and you have a collection of grades in your class and you want to maybe perform some analyses in R. So what I'm going to do this is I'm going to call an object called grades, and I'm going to set it equal to this seq function, which stands for sequence. So we want to create a sequence from 60 to 100 at intervals of 5. So the first argument in the sequence function is going to be from, so that's where we're going to start our sequence, and then we're going to use the to argument, which is going to be where we want to end the sequence, and then we're going to use this by argument, which is going to be signify the intervals within our sequence. So if I run line 13, I can print out this object called grades, holding Control and Enter, or by clicking the run button, and you can see that when we run line 14, we have this object called grades, and it's equal to 60, 65, 70, and so on, all the way to the number 100. So looks like we've been able to successfully create a vector from 60 to 100 that is spaced at intervals of 5. So now that we've done some of those basic analyses, we'll move on to something a little bit more complex, where we're going to create random grades for 3 classes. So in this example here, this is not the most realistic scenario. Obviously, if you had if you were a teacher, you would have grades that weren't spaced out only at intervals of 5. You might have a random collection of grades. So let's create objects that signify random grades from 3 classes of 10 students. So in order to create random grades, first I'm going to create an object called class 1. This is where I'm going to store all of the grades from the first class. And I'm going to use this rnorm function. So rnorm stands for random numbers from a normal distribution. So if you're not familiar, a normal distribution is essentially a bell curve where you have most of your values centered around your mean, and then you have your standard deviation or your variance that signifies how narrow or wide your distribution is. So I'm going to use this rnorm function. I'm selecting random numbers from a normal distribution. The first argument is going to be how many numbers I'd like to select, which is going to be the number 10. And then I'm going to use this mean argument, which I'm going to set at 80. And then I'm going to use the SD argument, which stands for standard deviation. And I'm going to set that equal to 5. And actually, I want to do one other thing before I run this rnorm function. I'm actually going to set my seed. So the set seed function or argument is essentially is a helpful tool when you're collaborating with other people, or if you're taking a course or following along in a video such as this, where essentially it makes sure that all the collaborators are selecting the same set of random numbers. So I'm going to set my seed at 100, and then I can run line 20. We can take a look at the numbers in class 1. So we see that we have numbers 77, 80, 79, and so on. So these are random numbers selected from a normal distribution with a mean of 80 and a standard deviation of 5. So after we create the numbers for class 1, let's move on to class 2. Again, I'm going to set my seed. This time I'll set it at 200. Give myself a little bit of space here. And then I'm going to call this object class 2. Again, I'm going to use the rnorm function, selecting numbers from a normal distribution, and I'm going to select 10 random numbers. This distribution is going to have a mean of 70, and it's going to have a standard deviation of 2, so it's going to be a narrower distribution. And I also want to add another function to this argument on line 24. I'm actually going to use the round function. So the round function is going to turn decimal values into integers. So you can see in class 1, we had values that had decimals in them, but we're going to use this round function. And again, I think I covered this in class 1. When you have multiple different functions on one line of code, you always work in, out. So the first thing R is going to do is select the random numbers, and then it's going to work on the functions on the periphery, which we're going to subsequently round those values last. So I can run class 2, and then we can take a look at them, class.2, and we can see that we have values ranging from 68 to, I think, 73, and they're all integers because we rounded all of the values in this example. So that looks good. And now we're going to move on to class 3. So I'm going to set my seed again, and I'm going to call this object class.3. I'm going to also use this round function again, and then I'm going to use the rnorm function. We're selecting another set of random numbers. We're going to select 10 of them, and this is going to be our smartest class. We'll have a mean of 90 and a standard deviation equal to 4. So that looks good. And now I can type out class.3, and we can see that we have numbers ranging from 90, I believe, to 95. So we were able to successfully select those random numbers. So now I think we're going to move on to our first in-class assignment. Just going to type out in class assignment. So in this first class assignment, it's pretty basic. What I want you to do is I want you to find the sum, the mean, and the standard deviation of all three classes combined. So I want you to find what is the sum, mean, and standard deviation of all three classes combined. So you guys can pause the video now, work on this for a couple minutes, and tune back in, and I'll show you guys the answer. Thanks. Hi guys, and welcome back. I hope you are all successful in finding the sum, the mean, and the standard deviation of all three classes combined. And now I will be showing you guys the answer. So we'll start off by giving ourselves a little bit of space in our R script. And I'll start by creating a new object called sum.grades. And then I will set it equal to the sum of class 1, class 2, in class 3. And if I run that line of code, we can see that we have sum.grades printed up in our environment. And I think I've been demonstrating to you guys how to print objects by simply writing the object and then running the line of code. But there are a couple different functions that can be used to do that. Sometimes they can be helpful in other data analyses that you guys work with. So we can use the print function. So if we simply write print and then we put sum.grades within the print function, we also get our 2431 printed out that way. And lastly, we can also use the paste function where we can put sum.grades and run that line of code, and we can actually paste the value of sum.grades. It's going to put it in parentheses, but those are just a couple different ways of printing values in R. So now we have the sum of all the grades, which is 2431, but we also wanted to find the average value of the grades. So if I type, I'll create a new object called average grades, and then I'll set it equal to the mean of class 1, class 2, and class 3. And when I run that line, we actually get an error. So you can see that error is printed out in our R console. Error text will always be in red. So that shows you that there's a problem going on in your R code. So what is this error? Well, if we read it, we can see error in mean.default. The trim must be numeric of length 1. The condition has a length greater than 1, and only the first element will be used. So that doesn't look good. Actually, let's take a look under the hood of the mean function to actually see how it's operating. So if you want to better understand a certain function in R, you can use this help window. So I'll start off by writing on line 46, I'm going to type a question mark, and then I'm going to type the function that I'm interested in. So we want to understand how R is interpreting the mean function. So I'm going to use a question mark and then the function, and then I'm going to run that line of code. And then in our bottom right-hand window, we can see that the help function is now describing the function, which is mean. So if we look at mean, it looks like we're going to start off, the first element of the mean function is an object called x. So that's the object that you would like to find the mean of. So we can see that the argument here is x. X is an R object. Currently, there are methods for numeric and logical vectors and date and time intervals. Complex vectors are allowed for trim equals 0 only. Okay. So if we look also, if we scroll all the way down in our help menu, we can look at a couple of different examples. So let's say we had a vector that was called x, and it was equal to the values from 0 to 10. So if we took the mean of all those values, we would get a certain answer. It doesn't actually give us the answer, but we can see that when we're
of trying to find the mean of a given value, we can only have one value. So I think the error that was occurring on line 45 is that we're trying to find the mean of class 1 and class 2 and class 3, but R only wants you to give one object. We have 3 different objects they're trying to find the mean of. We actually need to combine all of those objects into one object, and then we can find the mean. So how are we going to combine all of the grades from 1, 2, and 3 and store them in as one object? Well, we're going to have to use the concatenate function that I think we described in class 1. So we can do that by creating a new object called all grades, and we'll set it equal to the concatenate function of class 1 separated by a comma, class 2, and then separated comma, class 3. So we're going to combine all of the grades in the 3 classes into one object that's going to be called all grades. And then we can run that line, and in our console we can take a look at all grades, see what it looks like, and we can see that all of the grades from the 3 classes are now printed out and stored in the object called all grades. So now I think we'll be able to find the mean of the 3 classes. So let's say I'm going to create that other object, all grades, that we wanted to create earlier, and then I'm going to use the mean function, and then I'm going to find the mean of all grades. So if I run that line of code, we don't get an error function, which is good. We can see that the text is blue and R was successful at running that analysis. And then we can type in our R script and print it out and run line 50. And we can see that the mean of all of the grades in the 3 classes is equal to 81. So just an important concept when you deal with that error message that we had earlier, that's because you can only find the mean of one object. You can't find the mean of 3 separate objects. You have to combine those objects into one object, and then you can find the mean. So looks like we are doing pretty well. Let's actually take a look at the classification of the object called average grades. So we can do that by running the class function on average grades. It looks like R is understanding average grades to be a numeric variable, but let's say we wanted to turn that into an integer variable. So we want to maybe get rid of those decimal places and just have it stored as a round number. So let's create an object called int.average grades. And we can set it equal to, let's use the as.integer function, and we're going to round the value of average grades. So again, we're going to work our way from in to out. So first we're going to round average grades. So hopefully that will change it to the value 81. And then we want to tell R to convert that numeric variable to an integer. So if we run line 53, then we can look at the structure of int.avgrades. We see that R is now interpreting this value as an integer, and it's stored as the value 81. So those are just a couple important concepts. I don't think I actually asked you to convert the values, but just kind of building on some of the things that we were working on earlier. So I think the last task that I asked you guys to do was to find the standard deviation of all the grades. So let's create an object called standard deviation grades, and we'll set it equal to the standard deviation of class 1, class 2, and class 3. And it looks like we're getting another error. We get the red text says error in standard deviation, unused argument class.3. Now I'm probably going to assume that the same issue that was occurring on line 45, where we were trying to find the mean of multiple different objects, we probably just need to store these classes as one object. So we've already done that when we created all grades on line 48. So let's actually do something similar where we can create an element called standard deviation grades, and we'll set it equal to the standard deviation of that object we created earlier, which is called all grades. So if we run that line, we don't get an error argument, and we can print out the object by typing on line 59 and running that line, and it looks like the standard deviation of all of our grades is 9.7. So hopefully you guys were able to work on some of those questions on your own, but if you didn't, that's okay. You have the answers now. And now we will be moving on to the next section of our course, which I'm going to call Working with NAs. So what are NAs? Well, they're essentially null values, or values that R is having a difficulty interpreting. They're not numeric variables, they're not character vectors, they're kind of just blank or null values. So let's create an object by that's called allgrades.nas. So we're going to use that previous object called allgrades, but we're going to add an NA value to it. So I'm going to set it equal to, I'm going to use the concatenate function because I'm going to add an NA value to the original object called allgrades. So I'm going to type allgrades. And then I'm going to put a comma, and then I'm going to type NA. And as you probably have noticed, when you type NAs in our R script, they actually are interpreted, they're actually printed in blue, kind of like when you put a numeric element in our R script. You can see that numbers are in blue. So NA values are also in blue in our R script. And if we run that line, let's take a look at how R is now interpreting this object called all.grades.nas. And we find that this object is equal to all of the grades that we've previously have worked with, but on this 31st element, we have an NA. So we have all the grades that we were working with earlier, and then we have this last grade, which is an NA. So let's try to, and this is why I demonstrate this example with NAs, is that NAs are very common in all sorts of data sets that you'll work with in all different industries. And all the functions that are built in R interpret NAs differently. So let's try to find the mean of this new object called allgrades.nas and see how R interprets these values. So as you can tell, R is not actually able to find the mean of all grades when there's an NA value. Obviously, its output is in black here. We're just getting an NA. So let's go back to that help window that we were working with earlier. We can see that we're working with an arithmetic mean and the mean function, but there's this interesting argument that's called na.rm, which says a logical value indicated whether NA values should be stripped before the computation proceeds. So there is an argument in the mean function that is designated by na.rm, which actually stands for NA remove. So R will remove NA values, and then subsequently it will interpret the mean of a given object. So that's actually what we wanted to do because you can't take a mean of an NA value. So we can work with NAs in the mean function by trying to find the mean of all grades.nas. And then we're going to use a comma, and we're going to put this argument na.rm, and we're going to set it equal to true, which is going to tell R to remove the NA values before you find the mean. And if I now run that line of code, we see that the allgrades.nas is actually equal to 81.03, which I believe is the value that we had earlier. So when you're trying to find the mean of a vector that has NA values in it, you want to use this argument na.rm and set it equal to true, which tells R to remove the NA values before you find the mean. So let's Now move on to a standard deviation example with NAs. So I'll use the standard deviation function, and I'll type all grades.NAs. And again, we're getting an NA value because R is not able to find the standard deviation of a null value. So again, we're going to use that na.rm function. We will type SD, the standard deviation function, put in our object, which is called all.grades.NAs. And then we're going to use the na.rm, the na remove argument. We're going to set it equal to true. And now if we run that line, we get that value that we got earlier, which is 9.71. When we remove the NA value, then R is able to subsequently find the standard deviation of your vector. So let's move on to our second in-class assignment. And in this assignment, I actually want you to find, how would you code code 8 sequences of 10 to 100 at intervals of 5. So I'll just formally write this out. How would you code 8 sequences of 10 to 100 at intervals of 5? So this is going to, I'll give you a hint. This is going to involve the rep and sequence functions that we touched on earlier on in the course. And this is just, this hopefully will be a short assignment. Just should take you a couple minutes, but you can pause the video and tune back in and I will show you guys the answer. Thanks. Hi guys, and welcome back to our video. I'll be showing you the answer to the second in-class assignment. So let's start off by creating an object called long.sequence. And you can name it whatever you want. That's just the name that I'm going to use. So I'm going to create an object called long.sequence. And then I'm going to use the rep function. And then I'm going to type sequence. And I want a sequence from 10 to 100. And I want to be this sequence to be at intervals of 5. And then I want to repeat this sequence 8 different times, right? So my question earlier was, how would you code 8 sequences of 10 to 100 at intervals of 5? So to answer that question, first you have to create one sequence from 10 to 100 at an interval of 5. Which is done right here. And then you want to repeat that sequence 8 different times. So again, work in, out. So we first create one sequence from 10 to 100 at intervals of 5, and then we're going to repeat that function 8 different times. So if I run that line of code and then let's take a look at it. Okay, have to run it. We find that we have a very long sequence. It's over 130 different unique elements. And it looks like they're ranging from 10, 15, 20, 25, 30. That's going to go all the way to 100. Then it's going to repeat again, 10, 15, 20, all the way to 100. And then we're going to do this 8 different times. I'm not sure exactly how many unique elements are in there. I guess it should be... I'm not exactly sure, but in order to, if you want to find the length of a given vector, so how many unique elements are in a vector, use the length function. So I'm going to use the length function, and then I want to find the length of long sequence because I'm not really sure how many unique elements are in this sequence called long sequence. So on line 82, we're going to use the length function and then run that. And we find that the length of long.sequence is equal to 152. So we actually have an object that's a vector of 152 unique elements. So that's pretty long. And hopefully you guys were able to find that answer. But if not, it's okay. Just keep following along with these answers, and I'm sure you'll learn a lot along the way. So now we're going to move on to the next section in the course, which is types of data sets. And we're going to work with matrices, data frames, and lists. So let's start by creating a matrix. So what is a matrix? Maybe you guys have taken other mathematical courses and you're familiar with a matrix, but a matrix is essentially kind of this gridded data set where you have a series of different columns and you have a series of different rows, and then you're storing values within this data set. And they can be very long and complicated, but we'll be working with a couple of simpler ones in these examples. So let's start off by creating an object called mat.data. So it'll be standing for matrix data. And then I want to create a matrix. So I'm going to use the matrix function, which helps us create matrices. And then I'm going to start off with the first argument, which is data equals. And I actually want to use all of the data that are going to be in this matrix are going to come from this in-class assignment that we worked with from a long sequence. So the data in the matrix is equal to long sequence. The number of rows in the data set are going to be 19. Because within one sequence from 10 to 100 at intervals of 5, those are going to be, I think there's 19 different unique elements from 10 to 100 at intervals of 5. So we want 19 different rows, and then the number of columns is going to be equal to 8 because we repeated that sequence 8 different times. And so you can have matrices that are populated either by columns, or you can populate matrices by rows. So we want to actually populate our matrix by columns. So we're going to set this by row element argument, and we're going to set it equal to false because we want to populate our matrix by columns. So just in synopsis here, we're creating a matrix. The data within the matrix is going to be equal to the values in long sequence. We want the matrix to have 19 different rows because that's how many elements are in one of these sequences. And then we want to have 8 different columns because we repeated each sequence 8 different times. And then we want to populate the matrix by column. So we set the by row element argument equal to false. And if I run line 89, and then I can type out mat.data, we look in our console and we have a matrix that's equal to the data in a long sequence. We have 8 different columns. We have 19 different rows. So, and the values are at that 5 numeric interval where we're going from 10, 15, 20, 25, 30, and that sequence is repeated 8 different times in all of the different columns. So we have successfully created our matrix. And another way we can look at the data, in addition to looking at it in the console, is that we can use this view function. So let's say we type out view, and then we click mat.data, and then we run line 91. We see that a new window opens up kind of in our R script, and we have all of the different values that were in mat.data. So this is just another example of how you can view data in R. We can look at it in the console, but we can also look at it by using this view function. So I typed view, and then I typed in the data set that I wanted to look at, and it opened up this new window for mat.data. And now I think we'll be moving on to another example. So we create a matrix from long sequence, but let's create a matrix where we were working with the grades from the 3 classes that we created earlier on in this course. So let's create an object called grade.matrix, and we'll set it equal to a matrix constituted by data from all.grades. Again, all.grades was the object that was constituted by class.1, class.2, and class.3. And the number of rows in this matrix is going to be equal to the length of all grades divided by 3. Okay, so that's a little bit of a complicated argument. Hopefully you guys are able to follow. So how many rows are going to be in this matrix? Well, each class, I believe, had 10 different students. So all grades should be equal to 30 unique elements. And I want each column to represent all of the classes in each grade. So if I find the length of all grades, which should be 30, and then I divide it by 3, because there's 3 different classes, we should get a value of 10, which is what I intended, because this matrix is going to be, in column 1 is going to be class 1, column 2 is going to be class 2, and column 3 is going to be all the grades in class 3. So because we have 10 different grades in each class, our n row argument, so the number of rows, is going to be equal to 10. And maybe you guys noticed earlier, but I actually, I clicked enter, which brought this parentheses down to line 94. So when you're writing code in R, on line 93, I could go all the way horizontally and keep typing arguments farther and farther to the right, but sometimes that can get very difficult to view. So something that is very common in R script is that you can actually just click enter, and you can continue writing your code on the subsequent line with the same function. So sometimes that's a little bit easier to work vertically as opposed to horizontally. So our number of rows is equal to 10, and then the number of columns, the ncol argument, we're going to set that equal to 3 because we have 3 separate classes. And then our by row argument, we're going to set to false because we want to populate this matrix by columns. So let's say I run line 93, and then I can take a look at grade.matrix, and looks like we have three columns for our 3 separate classes. The grades are kind of in the 70s and 80s and 90s. So I believe that the mean of class 1 was an 80, class 2 I think it was a 70, and class 3 was a 90. Those grades look appropriate. I think we rounded only in classes 2 and 3, and we didn't round in class 1. So all those data make sense, and I'll just use this view function, which I showed earlier, which is just another way of looking at a data set. And if I run that line, we can look at grade.matrix in this new window, which is sometimes a little bit easier for me. I think I prefer looking at the data in this window, and just another example of how you can view data in R. Now we've worked with matrices, and now we're going to move on to data frames. And a data frame is very similar to a matrix, except that it has names for our columns, and they also can handle both numeric and categorical or character type elements in our data set. So I'm going to create a new section in our code, which is going to be called data frame. And then I'm going to create a data frame that's called grade.df. So it'll stand for grade data frame. Then I'm going to use the data.frame function. And I'm going to type in class.1, class.2, and class.3. So hopefully on line 99, we will be able to create a data frame consisting of 3 different columns, and each column will consist of the grades in class 1, 2, and 3. So I will run line 99, and then let's take a look at our data frame. So I'm going to type grade.df, and I can look at the whole data frame simply by just printing it. We can see our 3 different columns. The grades in class 1, class 2, and class 3. And now we have column names represented on all of our columns, which wasn't the case when we had a matrix. And I'd also like to show you guys another important concept when you're working with data frames, which is that you can use the $sign. So I type the name of my data frame, and then I put a $sign, and then we can see that R automatically opens up a couple different tags for our 3 different columns. So if you ever want to call a specific column within a data frame by its name, you can type the name of the data frame and then use a $sign, and then we can select unique columns this way. So if I run line 101, we see on our console that it outputs all of the elements of class 1, which is our first column in the data frame called grade.df. So let's say I wanted to find the mean of all the grades in class 1. So what I can do is I can type the mean function, and then I can type my data frame, and then I'm going to use the $sign to call class 1. So I'm finding the mean of the column called class.1 in the data frame grade.df. And if I run that line, we see that the average grade in class 1 is equal to 79.91. But let's say I wanted to find all of the mean values within all of the different columns in grade.df. So a very important function to understand when you are working with the data frames is the summary function. So this will synthesize a lot of the different statistics that'll be important for analyzing a data frame. So I'm going to use the summary function, and then I'm going to call grade.df. And when I run line 104, we see that R is able to output the mean, the first quartile, the median, the mean, the third quartile, and the maximum value for each one of our 3 columns. So this is a very efficient way of synthesizing data and analyzing data within a data frame. It would be very tedious to type out the mean and minimum values for each one of our 3 columns. That would be very tedious. So we can simply call this summary function, and we can get all of the summary statistics for all of the columns in our data frame. So that's a very effective way of synthesizing data in RStudio. So I'd also like to besides synthesizing data, I'd also like to give you guys some practice with data processing and working with data and organizing data. So I'm going to give you guys an example where we're going to create grade.df, and we're going to set it equal to a data frame. But we're just going to start off with class.1, and we're going to also have class.2. So right now we only have 2 classes in our data frame, and we can look at grade.df by typing it in our console, and we see that we only have our 2 classes. But let's say I wanted to manually add one class.3 to grade.df, and as opposed to typing it all out like we did on line 99. If I wanted to add one specific column to a data frame, I can actually just type the data frame of interest, and then I'm going to use the $sign. So I'm actually creating a new column. So I wanted to create a class called class.3. So this new column will be called class.3, and then I'm going to set it equal to the grades in class.3. So when we can call certain columns again with this $sign, but we can also create new columns by using the $sign as well. So I'm going to create a new column called class.3 and set it equal to all of the values in class 3. And when I run that line, we can now look at grade.df and see if it actually changed. And we can see that we successfully added a 3rd column called class.3 to our data frame called grade.df. So that's one way to add a column to a data frame. But I also want to show you guys a different methodology, which uses a very basic R function that you guys should be able to familiarize yourselves with. So we have, again, we're calling the function data.frame, and then we're going to have class 1, we're going to have class 2, class 2. So this new data frame called grade.df, it's going to rewrite over the original one which had 3 columns in it. So now we want to manually add class.3, not using the $ symbol, but actually using a basic function. So what I'm going to do is create a new object called grade.df, and then I'm going to use the cbind function. So cbind stands for column bind. So you have a data frame, and then you're combining another column to this original data frame. So the first argument in my cbind function is going to be the data frame. So it's going to be grade.df, and then I'm going to add class.3 to this data frame called grade.df. And hopefully we can check out in our console if R was able to combine that column. And you can see that we were successful, that we were able to add class.3 to the original data frame. So those are just 2 different ways of adding columns to a data frame. We can use the $ and then manually creating a new column, or we can use the cbind function to attach a column to an existing data frame.
So now that we've learned how to successfully add columns to a data frame in R, let's actually add rows to our data frame. So when we're adding columns, we're adding new classes, but think about adding new rows as adding new observations or new students to a given class. So I'll start off by creating a new object called new.grades, and I will set it equal to 3 new grades, the first of which will be a 70 in class 1, an 83 in class 2, and an 85 in class 3. And I can run that line of code, and then we can add it to grade.df, and we do that by using the rbind function. So similar to cbind, which combines columns, rbind combines rows. So we're going to use the rbind function, and then we're going to type in our grade.df, and then we're going to add new grades to grade.df, and we can run that line and then take a look at our new data frame in our console, and we see that we have successfully added this 11th student to class 1, class 2, and class 3 with values of 70, 83, and 85 respectively. So looks like we were successful at doing that, but I actually want to add one more student and get a little bit more practice using the rbind function. So now I'm going to create a new object called more grades, and I'm going to set that equal to 3 separate grades using the concatenate function, first of which is a 65. Next, I'm going to have a 90. And then my third class is going to have a 79. And then I will save more grades. And then I can add it to my data frame by using the rbind function. And I'm going to type grade.df. And then I'm going to hopefully add more grades to grade.df. I'm going to run line 117, and we can take a look at this new data frame grade.df. And now we have 12 students. So we successfully added line 116 more grades. So we have on our last row, we have a 65, a 90, and a 79. So hopefully you guys are comfortable adding columns and rows to data frames in R. And now we're going to move on to the next section in our code, which is going to be entitled dates and finding sums of columns and rows. So I'm going to start this section off by creating some month and year columns in for our data frame called grade.df. So most data have a temporal aspect to them. So you can think of these grades being collected obviously at a given
specific place and time. So we want to add a year column and a month column to this data frame to give us some temporal resolution. So I'll start off by creating a new column in grade.df, and we're going to call this new column year. And then the year is currently 2022. We can think of all of these grades being collected this year. So I'm going to set all the values in grade.df to 2022. And I'll run that line of code, and maybe we can take a look at it in our console. And we have successfully added a fourth column to grade.df entitled year, and all of the values are equal to 2022. So that's great. So now I'm going to add a new column, and it's going to be called month. So I also want to have a month column, and I want the month to be equal to this month.ab. So you can see that there's the purple tag associated with this index here, month.ab. So R has a couple different objects that are built in with it. So month.ab stands for month abbreviation. So those are going to be 3-letter month abbreviations from January to December. And we can run that, and we'll take a look at it in our console by typing out grade.df. So now we have a year column, which is all of the values are equal to 2022, but our month column is actually equal to 12 different values ranging from January to December. So all of the months of the year. You can think of each row as a different month, but they're all taken within the year 2022. So now I don't want just a year and month column. I actually want to combine those into one column, which is a little bit more efficient in my data analysis. So I'm going to create a new column. It's going to be called month year. It's going to be equal to kind of a combination of both the year column and the month column. So in order to combine columns, sometimes you can use the paste function. So when you're just essentially pasting values from two different columns into one column, and we start off by using this paste function, and then you have to, the arguments are what you're actually going to paste. So I would like to paste the month column with the year column. And we can take, let's take a look at our data frame grade.df. And we can look at the structure of grade.df. Now we have 6 columns, and this new month year column that we created is actually a character vector, and it's equal to the first element is the month abbreviation. So we have January, and then the second element is this year, which all of them should be 2022. So it looks like we were successful at combining the columns from year and month into one column called month year. So now let's move on to working with dates. So as you can tell, R is currently understanding this month year column as a character vector, but which is okay, but we don't really want it to be understood as a character vector. We want R to understand it as a date element. So how do we change this column month year to a date? Well, I can do this first by creating a new column. We'll call it grade.df $date. And then we want to change the month year to a date element. And we do that by using this, because it's a month year type of date, we can use, there's actually a function, I believe it's in the zoo package, called as yearmon. So you can just think of this obviously as a year month element. So this is going to convert our character vector, which is consisted of a month and a year to actually more of a date element so R can work with it more properly. So I'm going to type out our month year. And then I'm going to need to tell R how it would like to interpret this month year. So there's an argument in, let's actually take a look in the help function where we can type out in our console the question mark and as.yearmon. And then we can look in our help window, and hopefully that gives us a little bit of context of how to change characters into dates in R. So I think this is kind of the syntax that I'm going to be looking for, because here we can see that there's a 3-letter month abbreviation followed by a year. So I think the syntax for that is we're going to need a $sign, a lowercase b, and they used a lowercase y. I think that's because they have a 2-numbered year, but we want a 4-numbered year. So I actually looked this up previously to class, but I can give you some more information about how to work with years and months and dates in R. But just so we can follow along for now, you can just copy the argument that I'm going to type here. So the $sign lowercase b, that's going, oh, sorry, not the $, the %sign lowercase b, that's going to equate for a 3-lettered month. And then we're going to use the %sign again, and we're going to use an uppercase Y. So the lowercase b represents a 3-lettered month abbreviation, and a capital Y stands for a 4-numbered year. So if I run as.yearmon with this syntax, now let's take a look at the data frame called grade.df. And we can see that this date column is being understood as a yearmon, a year month, and we have the same values, but January 2022, February 2022, but it's being understood as a year month element, which is what we originally intended. So because it's being understood as a date, we can actually work with it more effectively in R. We can actually create plots that are quite informative. So let's actually plot our data. We can do this by using the plot function. And first I'm going to start off by typing my X variable, which is going to be, let's see, we can have our date here. And then we can have grade.df, and we can type out class 1. And I'm actually going to show you guys another example of why it's helpful to have dates being understood as year months or dates rather than character elements. So in order to demonstrate that comparison, I'm going to type out the original month year. Then I'm going to have class 1. So this first plot on line 130 is the original character vector month year. And then on line 131, this is the date column, is when we converted the character vector to a date. And hopefully R will demonstrate the concept that I'm trying to teach you guys. And yes, when we try to plot the character vector month year, we get errors because R can't plot a character. It's not properly understanding what the data mean. So if I run line 131, this is the vector that we successfully converted to a date, and you can see that R no longer gives us this error message, but we're actually successful at plotting the grades from class 1 over time. So when we had a character vector, we got an error, but when we converted that column to a date, we were able to successfully plot the data over time. So now I'll be moving on to a new section, which I'm going to call column and row sums. So I just want to show you guys a couple other basic functions that I think are helpful when you're working with data frames in R. So I'll start off by creating a new object called total class.1. And let's say I wanted to find the sum of all of the grades in a given column. So how would I do that? Let's say I want to find the sum of all the grades in column 1 for class 1. So there's a function I can use to find column sums, which is call sums. And then I'm going to need to type the column that I would like to find the sum of. So if I want to select the first column of a data frame, first I type the name of the data frame, and then I'm going to use a bracket. And then I'm going to type the numeric order of the column that I'd like to find the sum of. So now if we take a look at total class 1, we can see that the sum of all the grades in class 1 is 934. So again, just to reiterate, to find column sums, we use the call sums function. Then we type the name of the data frame, and then we use in square brackets the numeric order of the column that we like to find the sum of. But let's say I wanted to find the column sums of multiple different columns. So to do that, I'll type a new object called total classes. And then I will set it equal to the column sums of, I want to find the column sums of all of the classes. So I'm actually going to type the data frame, and then I'm going to use square brackets, and then I'm going to use the concatenate function. And then I'm going to type 1, 2, and 3. So I want to find the column sums of, sorry, I'm looking at some notes to make sure my syntax is correct. So column sums of grade.df, and I want to find the sums of columns 1, 2, and 3. Hopefully that code will work for us. And if I look at total classes, it's correct. We were able to find the sums of all the classes, 934, 875, and 1094. So just want to give you guys some more basic functions that'll be very helpful when you're becoming a data scientist. And also be mindful of the square brackets. That's kind of how we work with data frames or vectors and lists when we want to signify a specific element or order of the data that we're currently analyzing. So now after we find column sums, so the sums of classes 1, 2, and 3, now I would like to actually find row sums so we can find the total summed grades over each month. So let's start off by writing an object called total grades month. And we can set it equal to this function we will call row sums. And then we're going to type the data frame that we would like to work with. And then we're going to use square brackets, and we're going to type 1:3 because we would like to sum over the first 3 columns. We don't want to take the sums of the date columns. So we just want to find the row sums for the first 3 columns. And then we can run that line of code, and then we can go into our console and take a look at what the total grades month looks like. And then as you can see, we actually have the summed grades for each of the 12 months for our 3 classes. So hopefully you guys are able to reproduce some of the code that I'm working with, but now we're going to move on and move to our in-class assignment. And I want you to create a data frame of 5 different classes. And I want each class consisting of 20 random grades with a mean of 75 and a standard deviation of 5. And I also want you to find the mean and interquartile range of each class. And lastly, I would like you to add a new class to the data frame consisting of grades from 60 to 78 at intervals of 2. Okay, so just to recap here, I would like you to create a data frame of 5 different classes. Each class is going to consist of 20 random grades with a mean of 75 and a standard deviation of 5. And then I would like you to find the mean and interquartile range of each class. Just a refresher, to find the interquartile range, you're going to use that summary function that we mentioned earlier. And then lastly, I would like you to add a new class to the data frame consisting of grades from 60 to 78 at intervals of 2. So if you would like to get the same answers that I'll be working with, make sure to set your seed when you're creating each of these 20 random grades from each class. So we're going to have 5 different classes. You can set your seed for class 1 at 100, class 2 at 200, class 3 at 300, class 4 at 400, and the last class at setting your seed at 500. So you don't have to do that. That's just kind of an easy thing if you would like to reproduce the same results that I'll be getting. Hopefully you guys will be able to work on this in-class assignment, and you can pause the video and then tune back in when you're done, and hopefully we'll have the same answers. Talk to you soon. Hi, everyone, and welcome back. Hopefully you guys were successful at working on the first in-class assignment. So let's start off by setting our seed for class 1. I'm going to set that at 100. And then I'm going to call class.1. I'm going to set it equal to our norm. Random numbers from a normal distribution. Going to select 20 different grades. I want this distribution to have a mean of 75 and a standard deviation of 5. So if I run that, take a look at class 1, we see that we have a bunch of random grades. It looks like we have a mean of approximately 75. So I think we were successful at that. Let's work on class 2. We can set our seed at 200. And then class 2, we can have use the R norm function again. We're gonna have select 20 random numbers with a mean of 75 and a standard deviation of 5. Okay, now we're gonna have class 3. We're gonna set our seed again. You know what? I can actually just copy and paste this. We will work on writing functions later on in the class, which will speed up this kind of tedious process. I'm being it's a little bit redundant typing all of these classes, but we will work on writing functions where we can automate this process and make it a lot more efficient. As of right now, I'll do it kind of the slow version. So now we have 4 classes, and then I'm going to hopefully have my 5th class, which we'll call class 5. And great, so now we have our 5 different classes. We can take a look at them in the console. Class 1, we can look at class 2, we can look at class 3, and so on. So That's how you're going to find, I think that answers this section. Each class consists of 20 random grades with a mean of 75 and a standard deviation of 5. But I think I also wanted you to put them into a data frame. So now we have to combine all of those classes into a data frame. So I'm going to create a data frame called df.classes. I'm going to set it equal to this data frame function. And then I'm going to type all of my classes: class 1, class 2, class 3, class 4, and class 5. Okay, so I can run that line of code. I think it just popped up in my R environment. And I wanted you to find the interquartile range. And I gave you a hint earlier on that to find the interquartile range, you use the summary function. So I'm going to use the summary function, and I'm going to type my data frame classes. And we can look in our console and find that we have the interquartile range of each class. So class 1 has the first quartile is a 73. We have a median of 75. And then the third quartile, we have a value of 76. And they're pretty similar for all of the 5 classes because they all were selected from a normal distribution with the same mean and standard deviation. So that's not quite a surprise. And then after you created that data frame, I think I asked you to create a 6th class. We can call that class 6. And then I think, just to look at my question, I think it was add a new class to the data frame consisting of grades from 60 to 78 at intervals of 2. So you're going to use the sequence function to answer this question. So we want a sequence from 60 to 78, and we wanted this at intervals of 2. So we can run this line. It looks like we've successfully created class 6. And then I wanted you to add that to the data frame called data frame classes. We can call this class 6, class.6, and we can set it equal to the values in class 6. And if we want to take a look at what this new data frame classes looks like, we can actually, in addition to just printing it out like we've done earlier, where we just type it out and run the line of code. If you just want to look at the first 5 rows of a given data frame, a function that I like to use a lot is the head function, which will just show the top portion of your data frame. So I'm going to type head df classes, run that line, and we can see that we've successfully added this 6th class to our data frame called data frame classes. And that concludes this in-class assignment. And that also concludes all of the work that we've done in class 2 of Florida Data Sciences 24-part series, Introduction to Data Science. I hope you guys learned a lot today, and stay tuned for class 3. And I hope to talk to you soon. Thanks.